Okay, so today we're going to be looking at Facebook's Memcache, like how they use it and how it works.
Yeah, and it's a pretty fascinating system when you think about all the cat videos and messages and things flying around on Facebook every second.
Like, how do they even keep up with it all?
Well, that's exactly what we're going to be diving into, right?
Okay.
The sheer scale of Facebook's operation, billions of users, and how they manage to make it all feel so, I don't know, seamless.
So this deep dive is all about what? Like pulling back the curtain and seeing how the wizards at Facebook built this system.
Exactly. Like, we've got this research paper we're going to be looking at. It goes deep into how they scaled Memcache from a single cluster of servers to this massive global network that handles trillions of items.
Trillions. Okay, my brain officially can't even. So maybe let's start with something a little smaller then, huh? Like the basics of Memcache. What is it in a nutshell?
Okay, so imagine you're scrolling through Facebook, right? Every post, every picture, every comment, all that data.
It all has to come from somewhere.
Exactly. And usually that somewhere is a database. But databases can be kind of slow, especially when you have billions of people all trying to access them at the same time.
Oh, so that's where Memcache comes in.
You got it. Memcached is like this super fast in-memory storage system,
Okay, so in memory, meaning.
meaning it keeps the data right there in the computer's RAM, ready to be accessed super quickly, no waiting around for slow disks.
So it's like having the answers to a test right there on your desk, instead of having to dig through a textbook to find them.
Perfect analogy, and that's why Facebook uses it, to make sure that when you click on something, it loads instantly.
So no more staring at those spinning wheels of Ging.
Hopefully not. But even with Memcache, speed is still a huge challenge for Facebook.
Yeah, I mean, every millisecond counts, right?
Absolutely. They've done tons of research on this, and even a tiny delay can cause users to just like bounce, leave the site.
Yeah, we all have that short attention span these days, huh?
It's the reality, so they've had to come up with all sorts of clever ways to make Memcache even faster. Things like using UDP.
Honeypea.
Yeah, it's a faster communication protocol.
Right.
And parallel requests.
Oh, so that's like sending multiple people to the grocery store, instead of just one person trying to grab everything on the list.
Exactly. Divide and conquer. But then there's the issue of keeping all that data consistent.
Ah, yeah, because what happens if someone updates their profile in, say, Europe, and I'm trying to view their profile here in the U.S.?
That's the million-dollar question, right? How do you make sure that everyone sees the most up-to-date information, no matter where they are in the world?
Seems like that would be a nightmare to manage.
It is, especially when you've got databases spread out across different regions, each with its own copy of the data.
So how do you keep them all in sync?
That's what we're about to find out.
All right, I'm all ears.
Well, one of the key things they do is they build these like invalidation instructions right into the SQL statements that update the master database.
Okay, so the database itself is like helping to keep Memcache in sync.
Yeah, it's kind of like attaching a little to-do list to each update, saying, hey, Memcache, you need to get rid of this old data.
I see. So it's not just about updating the data itself. It's also about telling Memcache what not to keep around anymore.
Exactly. And to manage all these invalidations, they have this system called, and I love this name, McSqueal.
McSqueal. That's adorable.
Yeah.
So what does this little Memsqueal do?
Well, think of it as the middleman between the database and the Memcache servers. It's constantly listening for changes, right? And then it extracts those invalidation instructions.
So it's like a little spy sneaking around and gathering intel.
Pretty much. And then it bundles these invalidations into batches. So it's not sending a million tiny messages all the time.
Right. Got to keep things efficient.
Exactly. But here's where it gets even more tricky. We've got those replica databases, right? The ones spread out across all the different regions. They need to get these invalidations too.
Right, because we want everyone to see the latest updates, no matter where they are in the world.
That's the goal. But what if an invalidation message arrives at a replica database before the actual data update has arrived from the master database?
Oh, I see. That would be a problem. It'd be like getting instructions to remove a book from a shelf before the new edition has even arrived at the bookstore.
Exactly. Total chaos. So to prevent that, Facebook uses these things called remote markers.
Remote markers. Okay, what are those?
Imagine them like little flags that get placed on data in the replica databases saying, hey, this might be out of date.
So it's like a warning sign.
Yeah, basically. And when a request comes in for that data, the remote marker triggers a redirect to the master region where the most up-to-date data lives.
So it's like saying, hold on, this information might be stale. Let me redirect you to the source of truth.
That's a great way to put it. It's a simple but effective way to maintain consistency without sacrificing speed.
This is all very impressive, but I have to wonder, is perfect consistency even possible in a system this massive and constantly changing?
That's a really good question. And honestly, the paper kind of acknowledges that it's probably not.
So there's a trade-off then.
In a way, yeah, they're willing to accept a tiny bit of inconsistency to make sure that the system stays fast and responsive.
That makes sense. I mean, users probably wouldn't be too happy if they had to wait ages for a page to load, just because Facebook is obsessed with having everything perfectly in sync.
Exactly. It's all about finding that balance.
So we've talked a lot about caching database results, but I know Facebook uses Memcache for other things too, right?
Oh, yeah, definitely. It's way more versatile than just that.
Like what?
Well, for example, they use it to store pre-computed results from complex algorithms.
Okay, so like saving time by not having to recalculate things over and over again.
Exactly. And things like user session information, temporary data used for specific features.
So like a digital storage locker for all sorts of random stuff.
You could say that. And it's super useful because it means that engineers can quickly build and deploy new features without having to set up a whole new storage system every time.
That makes sense. Got to be efficient when you're dealing with billions of users.
Absolutely. But we've been talking a lot about the system as a whole, and I think it'd be fun to zoom in a bit now and look at how they actually optimize each individual Memcache server.
Oh yeah, let's get into the nitty-gritty. What kind of magic are they doing at that level?
So one of the things they did was implement fine-grained locking. It's a way of letting multiple threads access different parts of the data at the same time without, causing conflicts.
So it's like having multiple checkout lanes at the grocery store
Yeah.
instead of everyone waiting in one giant line.
Yeah, exactly. And they also introduced this thing called an adaptive slab allocator.
Adaptive slab allocator. That sounds, I don't even know what that means.
It's basically like, imagine a warehouse, right? With shelves that can automatically resize to fit different products.
Oh, okay, I see. So instead of having fixed size compartments, that might be too big or too small for certain data, they have a system that adjusts dynamically.
Exactly. It's all about making the most efficient use of the memory.
Clever. And then there's the transient item cache.
Ah, yes. That one's specifically for data that has a very short lifespan.
Like what?
Things like session data or temporary tokens, that kind of stuff.
So it's like the express checkout lane at the grocery store for people who just have a few items and don't want to wait in the long line.
Perfect analogy. And by getting rid of the short-lived data quickly, they free up space for the more important stuff, the stuff that needs to stick around longer.
So it's all about optimizing the flow, making sure everything runs smoothly.
Exactly. But here's something that I thought was really cool. They figured out a way to upgrade the Memcache software without having to take the whole system offline.
Wait, seriously? How is that even possible?
It's pretty wild, right? They basically modified Memcache to store its data in this shared memory region so they could update the core software while leaving the data itself untouched.
That's incredible. It's like swapping out the engine of a car while it's still running.
It's a pretty amazing feat of engineering.
It really shows how much they prioritize keeping things running smoothly.
For sure. And, it's just a small taste of the complexity that goes into building and maintaining a system like this.
Yeah, we've covered a lot of ground in this deep dive, from the basics of Memcache to all these crazy optimizations.
It's been quite a journey. We've seen how Facebook scaled Memcache from a single cluster to this globally distributed system, handling billions of requests every second.
And all the clever tricks they use to keep the data consistent. Leases, remote markers, mixed squeal, the whole shebang.
And how they've turned Memcache into this versatile tool that goes way beyond just caching database results.
It's really impressive stuff. Makes you
Yeah.
realize just how much ingenuity goes into making these systems work.
Definitely. And, it's a constant process of innovation and adaptation. There's no one-size-fits-all solution, and Facebook is always pushing the boundaries.
It's a good reminder that technology is always evolving,
Yeah,
and we need to keep learning and adapting too.
couldn't agree more. Well, I think that about wraps it up for this deep dive.
Yeah, I think we've squeezed all the juice out of this topic.
It's been a pleasure diving in with you.
Likewise. And to our listeners, thanks for joining us. We hope you enjoyed this exploration of Facebook's Memcache. Until next time, keep exploring.